Hello everyone, I'm Ben. Welcome to my YouTube channel. Today I will show you how to install NVIDIA modulus in the Docker, and we will run the simple example, which means lead-driven cavity. So we will use the Docker to pull and run and open in the Jupyter notebook and run the example. Then we will visualize our output result in the TensorBoard. This is the method 1 to visualize our output result. And the true solution is generated by openfoam, which you can check my previous video to use openfoam to generate this solution. And we will regard as this a true solution. Then in today we will use the PINN solution, which is using by modulus to generate this solution. Then in the end we will check the difference. In this case, PINN solution is very similar with true solution, so we can know the difference is very small in this case. In the method 2, we will use Jupyter notebook to view the result. So, okay, let's go the install step. So every step you should know. You can check this NVIDIA modulus documentation. This will show you how to install, but in this case I will show you my step. So first we need to pull the Docker, and before this step you should make sure your Docker is open. And open the CMD command line, pull the Docker image. So I will run the Docker. In this Docker run command line, I use the 80,888 as a Jupyter notebook port and the 70,007 as a Jupyter notebook TensorBoard port, and I use the memory as 16 gigabyte. Okay, so I will run this command line. Okay, after you run this command line, you will see they will giving you a URL port, which is Jupyter notebook port. So in this Jupyter notebook we can see there is a lot of things inside, but today I will need a tutorial in modulus thing. So I need to git clone the modulus thing, which is this GitHub. This GitHub will have the lead-driven cavity example. So we need to git clone this GitHub. Use this command line. In our Jupyter notebook, we need to create a new notebook and use. So after you git clone this GitHub, you will see the modulus thing directory is installed in your Jupyter notebook. So in this case, we will have the example LDC, which means lead driven cavity. Okay. Before we run this Python code, we need to prepare our openfoam result. If you haven't download openfoam and run the cavity result, you should check my previous video. In this video. Okay, so I will use the parallel view to save the data which we run in the cavity. So we open the parallel view. So in the parallel view, we should open the result we previously run. In this location. So you can see we have run the cavity result before, and we choose this type, group type. Okay, so you can see the result. And we need to export this result data as a CSV file. And the name we should name by this. So in the we will set the data as a CSV file. Okay. Then we need to upload the CSV file to Jupyter Notebook. So we need to in this directory. Then we can run the cavity example. So how to run cavity and show the result in the TensorBoard, you can check this link. So the cavity problem is like this. You will have the the u velocity up the cavity, and inside the cavity they will have some turbulence. Okay, you can see the problem description in this website. So we just need to run the example code. The example code didn't have the code to visualize in Jupyter Notebook TensorBoard. So you should add the code. You can check this link. So they will teach you how to visualize in TensorBoard. So we just need to copy this command line into layer LDC2D and save. So we just create a notebook and run. LDC2D Pi. Okay, after I done my training, I need to use the TensorBoard. Okay, and open the TensorBoard. So in the TensorBoard, we can see our P and U and V solution. And the training step. And we can see the difference. U and predict, true, predict, and then different. And the V. Okay. So in the second way, we need to use the Jupyter notebook to show the result. So in the method 2, I will show you run the Jupyter notebook to view the result. And you can download this Jupyter notebook. And upload. I have already done the code in this notebook, so you can just run. So you will see the pressure and velocity, and you can run this code. So you can see the vector field of U and V. And the string line. So in this case, we just use the Jupyter notebook to show and to visualize our result in the NVIDIA modulus. So that's all our tutorial in today, and thank you for your watching.